Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 5.1, day 3, entitled The Unit Circle. And today we're going to talk a little bit more about terminal points, but we're also going to focus on reference numbers or reference angles. And when we're dealing with finding terminal points, we have to know the corresponding terminal point in the first quadrant. So a tool that can be very, very helpful to us to do that is to find the reference number so that we can find the appropriate terminal point. Now the reference number is basically how far away your distance is from the x-axis. So it's the distance along the unit circle between the terminal point and the x-axis. So they're going to give you a certain distance that you want to travel around the unit circle. And then wherever that distance lands you on the unit circle, you're going to find how far you have to continue going or how far you have to go back to get to the x-axis. But it's always the x-axis. Okay, so they have a couple pictures here. So if they give you a distance t and you're in the first quadrant, well, your distance back to the x-axis is just that distance that you traveled. Okay. If you're going into the second quadrant, then you want to keep going and find how far you have to continue to go to get to the x-axis. So that's going to be your reference number. If you're in the third quadrant, same thing, except you're kind of going backwards now. You're kind of backtracking how far you have to go back to get to the x-axis. And if you're in the fourth quadrant, it's how much you want to continue to go to get up to the x-axis. Okay, so again, it's how far your point is, wherever you land, it's how far you have to go to get to the x-axis. Okay, so here's a couple examples to practice this. Okay, and it says to find the reference number. I think when you talk about this in Algebra 2, they call it the reference angle. Okay, it's the same thing. So you basically want to start by finding this location, the value that they give you for t. You want to find that location on the unit circle, and then you're going to see how much further you have to go to get to the x-axis. So again, draw a little picture. Draw your axes, and then we're going to start moving around our unit circle. So 5/6. Okay, so if you don't already know where 5/6 is, again, remember we're starting at 0. This is going to be pi. And so this denominator tells you how many sections you're cutting 0 to pi up into. Okay, so I'm going to travel 5 of them. So 1, 2, 3, 4, 5 sixths is right there. There's 5/6. Well, the distance that I have to go to get to the x-axis then is right here. That distance that I have to go is going to be pi over 6. Now, why this is a reference angle is because if I reflect this across the y-axis into the first quadrant, this 5/6 is going to have the same ordered parents terminal point as 1 pi over 6. It's just going to have different signs. So that's why this skill is important. Okay, so for part B, same thing. I'm going to draw a little picture of my axes here for my unit circle. Now I'm going every fourth. So that means from 0 to pi, they cut it up into fourths. So I've got 1/4, 2/4, 3/4, 4/4, which is pi. 5, 6, 7 pi over 4. So I'm right down here. Okay. So basically then to find my reference, that's how far do you have to go to get back to the x-axis. Well, I'm going every fourth, so my distance to get back to the x-axis is going to be pi over 4. And again, this angle right here is going to have the same ordered pairs as pi over 4 up here in the first quadrant. It's going to have the same terminal point ordered pair. So that's why this reference number or reference angle is important. Okay, for part C, now this is a negative measurement, so I'm just going to move backwards around my unit circle. So I'm going to start at 0 or 0 degrees or 0 radians. Okay, here's pi again. Now I'm going every third, so that means that they've taken this semicircle and they've chopped it up into threes. I'm going backwards, so I'm going down first, and I'm going to go 2/3. So I'm going to go 1/3 and 2/3. So right here is where I'm going to be. Now again, to find my reference angle or my reference measurement, my reference number, it's how much do I have to keep going to get back to that x-axis. Well, I've already gone 2/3, so I have to go another third, pi over 3. So that means that this angle where I stopped is going to have the same terminal points as pi over 3 in the first quadrant. Excuse me. Okay, now part D is a little bit different, and that's because they don't give us any pi's. They give us a decimal. 5.8. Okay, so to figure out any type of reference for this decimal, I basically have to convert the unit circle to decimals. Now I don't need to convert all of them, okay? We know that if we're dealing with our unit circle, we'd have 0 over here. We go around to pi. Pi is going to be 3.14. And then if I continue around the bottom, I'd come back to 2 pi, and that would be 6.28. Okay, so if I'm going 5.8, that means I start at 0, I go around to 3.14, and then I keep going until I get to that 5.8. Now, I don't know exactly where it is, but I know it's not all the way to 6.2. Okay, because 2 pi is 6.28. Okay, so I'm somewhere over in here. Now, to figure out how much I have left to go to get up to that x-axis, well, I'm at 5.8. I got to go however much is left to get me to the 6.28. So just do 6.28 minus 5.8. And that'll get you 0.48. So whatever terminal point that had, or this angle, this 5.8 with that distance, whatever terminal point that has, it's going to be the same as wherever 0.48 is up in the first quadrant, somewhere up in here. Okay, so you can use this concept with positive radians, negative radians, even with decimals. Okay, now we're going to switch gears just a little bit here, and we're still going to use our reference numbers, but we're going to use them to help us find terminal points. Okay, so we're going to be finding terminal points now, but we're going to use that reference angle concept that we were just doing to find the terminal point. Okay, so I want to find the terminal point for 5 pi over 6, 7 pi over 4, and negative 2 pi over 3. Now, I know these measurements are on the unit circle. If you have the little picture of the unit circle, you could just find 5 pi over 6 and write down the answer, 7 pi over 4, write down the answer, okay? But we want to use this concept of the reference angles. So we're going to practice that skill some more. So again, I'm going to draw my little unit circle here. I'm going 5 pi over 6, so that's over here. Okay, there's 5 pi over 6. Now I know my reference angle is going to be pi over 6. That That's how much I have to go to get back to my x-axis. Okay, so the terminal point that's right here at 5 pi over 6, that's going to be the same as whatever pi over 6 is in the first quadrant, except I'd have to change the signs so that they're appropriate for the second quadrant. Okay, so pi over 6, that terminal point, remember, was square root 3 over 2 and then a half. But I have to have that value now for the second quadrant. So that means my x value has to be negative, and then my y value has to be positive. Okay, so that's it. Now for part B, we're going to do 7 pi over 4. Now if you remember from the previous day's notes, I said that the 4s, everything that's over 4, is going to have the square root 2 over 2, because like 2 and 2 is 4. So we know it's going to have that. We just have to know what quadrant we're in. Okay, so I've got my fourths. So I've got 1, 2, 3, 4, 5, 6, 7 pi over 4s right here. Okay, so my reference angle then to get back to the x-axis is going to be pi over 4. So whatever terminal point I have here for 7 pi over 4, it's going to be the same as pi over 4 in the first quadrant. I just have to change my signs. So the pi over 4 is going to have the square root 2 over 2 and the square root 2 over 2. But if I'm in the fourth quadrant now, I have to be positive and then negative to get into the fourth quadrant. So my y value will be negative. Okay, one more. We're going to do negative 2 pi over 3. So again, draw your little axes. And since it's negative, we're going to go down and clockwise instead of up and counterclockwise. So I'm going to start on the x-axis, and I'm going to go down 2 pi over 3. So that means that this bottom semicircle is getting cut into thirds. So I want to move 1/3 and then 2/3. So I'm going to be over here. So that's negative 2 pi over 3. But the distance that I have to go to get back to the x-axis, that's going to be pi over 3. So pi over 3 is my reference angle. So whatever terminal point is here, it's going to be the same as pi over 3 in the first quadrant. So pi over 3, all the pi over 3's, remember I said you kind of count backwards. This is really your 60-degree angle. So then you also have your 45, and then you have your 30. And it kind of goes, 3, 2, 1 in your ordered pairs. So it's going to start with the 1/2 square root 3 over 2. But I'm in the third quadrant. Okay, for negative 2 pi over 3, that terminal point's in the third quadrant, so my ordered pair has to be negative, negative. So we're using all that information that we had about that first quadrant, and we're just kind of translating it into whatever signage we need for the appropriate quadrant that we're actually in according to our t value. So this is meant to be fairly straightforward. It's somewhat easy. If you think this is easy, that's good. But sometimes it's a little funky. It takes a little getting used to with a lot of mental skill and remembering what amount of a fraction you have to move and what terminal point goes with which fraction and which degree. So practice this. Okay. Now, there's a little bit of a trick that we can use to help us from going around and around and around and around the unit circle when we're given really big distances that we're supposed to move around the unit circle. So remember that anytime we go around the unit circle, we're going around 2 pi. So if they give you a huge value for t, if they give you a large value for t, then you can shrink that. You can subtract 2 pi and make it smaller. and just keep subtracting 2 pi until you get to a point where you can't subtract 2 pi anymore. Okay? And that will be your reference angle. So here's what I mean by that. Okay? We have 29 pi over 6. Okay, 29 pi over 6. So that means that they took the unit circle and they took this top section and they cut it into 6. Okay? So that means I'd go around and that'd be 6 pi over 6. And then I'd go another 6, and that would be 12. And then I'd have to keep going another 6, and that would be 18. And then another 6 would be 24. Okay, now I want to go 29 altogether. So 24, 25, 26, 27, 28, 29. Okay, so notice that when I end, I'm really at a much smaller terminal point than what I was given. So we can kind of find that shortcut. We could draw this if we needed to. I mean, this one isn't too terrible to draw. But we can also take 29 over 6 and we can subtract 2 over 1. So it's like taking 29 pi and subtracting 2 pi. Now when students do this, they make a common mistake. They do not find a common denominator for these fractions. So they take 29 minus 2 and they get 27 over 6. That's not correct. Remember, this 2 is really 12 over 6. We have to find a common denominator when we're subtracting fractions. So 29 minus 12, now that is 17 over 6. Okay, so if I go around the unit circle one time, I still have 17 over 6 that I have to go. So I'll subtract another 2, or another 12 over 6 in this case, and that gets me 5 over 6. Okay, and that's really 5 pi over 6. That's what this measurement is right here. That's 5 pi over 6 if you look at your unit circle. Okay, so I've subtracted 2 pi here, so that's one movement around the unit circle. I did another 2 pi there. That's another trip around the unit circle, just like I had here. I had one trip around, then I had another trip around, and then I went 5/6 more. Okay? So, in the second quadrant then, 5/6 is going to have the same terminal point as whatever pi over 6 is, because pi over 6 is my reference angle. So pi over 6 in the first quadrant, that's going to be the square root of 3 over 2 and the 1/2. Okay, because that's my 30-degree sector. Okay, so that was the 3, 2, 1. Okay, so it starts with the 3 here in my numerator and the x value. But I'm in the second quadrant, so I don't want positive, positive. I want negative, positive. So there's my terminal point for 29 pi over 6. Okay, so use that trick of subtracting 2 pi when you're dealing with large values. But remember, you have to have a common denominator. Okay, you need an LCD. You need a least common denominator. So if you're dealing with sixths, make sure that you're subtracting 12 over 6. If you're dealing with 4, make sure you're subtracting 8 over 4. If you're dealing with 3, make sure you're subtracting 6 over 3. Okay? So you're kind of subtracting double from the numerator, whatever your denominator is. So whatever your denominator is, in this case it's 6, double it, and that's how much you subtract from the numerator. Okay? So remember to find that common denominator. Okay, and there's just the book's version of what we did. So again, homework tonight is to practice these concepts. This is probably the trickiest stuff because you're using all of your knowledge now put together. Okay? Have a picture of the unit circle for reference if you need it. Try to memorize this and get this into your head and kind of get an answer in your head and then look at the unit circle to double check it. Okay? And remember, the work is all worked out in the binder in the classroom. And if you have any questions, come see me before school.